Hi guys, in this video we are going to discuss another interesting question from a series circuit alternating current waveform. Also in the previous video we have already discussed about those things. If you like to watch them, I have given the link in the description so you can always watch them. If you are new to this expert tutor channel, please consider subscribing. Okay, without wasting our time, we can directly jump into the question. So in this question they have given the source voltage with the respective time domain equation. Likewise they have also given for the equation for this current, and they have mentioned there are only two element series circuit. After that they are asking these 7 questions. So if you like to do this in your own, it would be much better. So please stop the video and try to do these questions. After that watch the rest of the video for the explanation. Okay, let's do this. So when we are considering about this, they are first of all they are asking to express the voltage and the current time domain equation in polar form. Actually we have already learned that when we are considering about the polar form, they are given this time domain equation. From converting this time domain equation to polar form, actually we need to find the RMS value of this voltage first. So how to find this RMS voltage is we can directly use the Vmax over root 2 over here. How we can use that? The simple answer is we have already proved that when we are considering about the sinusoidal waveform, we can directly use this equation, the V maximum over root 2, to find the RMS value for the sinusoidal waveform. So actually we have given this equation in the sinusoidal waveform, so we can directly use this one. If I simplify this, I am going to get 141.42 voltage. So the next question is how we got this Vmax. The Vmax is going to be this 200. Actually we knew that when they are given the equation in a time domain equation, when they give a time domain equation, we can directly tell this 200, the initial part would be the maximum value. So from that we can directly tell it's going to be 200 over root 2. From that we can get this one. After that, when we are considering about the polar form, we need to remember actually the RMS value, the magnitude of that polar is not enough. We need to give the angle, the initial phase angle. So when we are considering this equation, we can directly tell this part is going to return the initial phase, which is minus 30. Now we have found the values. After that we need to consider about this we actually knew that I is equal to 4 cos 1000 t minus 173. So the question over here is whether we can use this part directly. Yes, we can use that. When we are considering about the IRMS, it's going to be I max this value over root 2. So here, however, there is simple difference between here. If you consider this, it's having the value in this cosine. However, the problem is when we are considering these two in the same, from the same circuit, we need to actually check whether these two are in the same sign. Let's say if this is in the sign, we need to check, we need to change this part to sign to consider or to check these two angle, the phase angle with the same respective manner. So the question over here is whether these two are in the same sine trigonometric function. So the answer is simply we can tell actually we have solved the answer for this sine part, so we can change this part to sine, and after that we can find the initial phase angle of current with respective to the same reference line we have used for this voltage. So we need to change this to sine. Otherwise you can change this part to cos and find this phase angle. So since we have already found for this one, I am going to change this part to sine. So how we are going to change this part to sine? The simple answer is when we are considering, let's say this is known as theta. Let's say this is theta. So we can tell this is going to be cos theta. So how to change this for sine is we can tell cos theta would be equal to, in the other way we can tell the sine 90 plus theta is going to be equals to cos theta. In the other side we can tell sine 90 plus theta is equal to cos theta. So if we can directly substitute the 1000 t minus 173 over here, if you substitute that one, we will be getting sine 1000 t, this is angle 90. So we can tell if we deduct that one, we are going to get minus 83. Yes, minus 83 ampere. So now we have got the equation. it's not enough, we are going to find the IRMS value. We are going to use I max over root 2. If you use that one, we are going to get 2.823. You're going to use this part and you're going to use this equation and solve this one. After that, we need to find the angle. We can tell the initial phase angle would be sine omega t plus phi. The phi is the initial phase angle, so we can tell the initial phase angle would be minus 83. We can directly write it in the polar form, 2.823. The angle simple minus 83 ampere. So the first part is over. So when we are considering about the next question, they are asking about the draw these two phases. So which simply means the phases is, we have already learned about this one. When we are considering about the phases, it simply means we are going to draw these two in a same image, same diagram. That is known as phasor diagram. So when we are considering about this one, we actually knew that, let's say this is a reference line of that. We are going to consider a reference line. If we consider a reference line like this one, we can tell the angle would be minus 30 from this reference line, which simply means we are going to take in the negative direction. It's going to be in this direction. It's going to be minus 30. So the first part is over. We need to draw this one and mark it like V, the voltage, or we can directly write as VRMS, which is equals to 141.4. So the next part is we are going to draw this one, the I phasor, in the same diagram. If we draw that, we can tell it's going to be in the minus 83 phase angle. So be careful, it's going to be near to this line, 90, near to this line. And check this line is going to be smaller than, very smaller to this line, as this is 141.42, it's going to be 2.823. So we can tell it's going to be IRMS, which is equal to 2.823. Other than that, you need to mark this angle, it's going to be minus 83. Yes. So these are the important things you need to mark in the phasor and phasor diagram. So the thing over here is whether this is the only phase diagram you can draw for these two phases. No, you can draw in many ways. Let's say you can take the voltage as a reference line and draw the voltage line in the straight line. If we take the reference line like this voltage, we can tell the voltage is going to be in the reference line, and this I would be 53 degrees downwards, or in the clockwise direction for this voltage. Let's say if we consider the voltage as the reference line, we can directly tell this is the reference line. If we draw the voltage in the reference line, we can directly tell the I is going to be in the clockwise direction, in the angle would be minus 53. You can also show like this one. However, this is the most common way, as they are given these two phase angles. However, this is also the correct one, so you can always use this. So the next part is find the phase of voltage with respect to current. So they are asking about the phase of this voltage line with respect to current. So we can tell when we are considering the voltage from this current with respect to this current. So we need to consider from this part. If we consider about the voltage, it's going to be lead this current. So you need to write it like this: V leads. You can't tell, it's not proper to say I lags this voltage by 53. The reason is we are going to take from this part. So if we consider this part, it's going to, the voltage is going to be leading this I current. So V leads I by the angle would be 53. So if they ask with respect to voltage, we can tell the I is going to be lagging by 53. So in this question, they are asking about the voltage with respect to I. So we are going to give in the lead, V is going to lead this current. So that's the answer. So the next part is express the impedance of the circuit in polar form. So here we need to find the equation in the polar form. Let's say this is fourth part. I'm going to use this one fourth. So when we are considering about the impedance, we can directly tell it's going to be V over I. Actually, we knew that voltage in the polar form. We can directly write this one 141.42. The angle of this is minus 30, and this part is 2.823 minus 83. So over here, how to simplify this is very simple. You can directly divide this magnitude RMS values, both RMS values, directly, and after that you need to deduct this from this part. Let's say if I directly divide these two, I am going to get 141.42 divided by 2.823. I'm going to get 50.095. And if I deduct this part from this one, I'm going to get minus 30 minus 83. So it's going to be totally, the resultant would be 53, positive 53. So this is known as impedance. However, you can also use the calculator to solve this one directly. So however, it's not difficult to deduct these parts and divide this part using calculator. Otherwise, you can use the polar sign. You can directly use the complex number form and write the equation in the polar form, 141.42, angle of minus 30 in this calculator. After that, divide it by another polar form like this one, and you will be getting the answer in this polar form. You can also use this calculator and directly find this one. However, it's not difficult to do manually these two. So if you like to watch that video, I have given the link in the description, so you can always watch them. Okay, so the next question is voltage differences between each element. So actually we have found the total impedance of this one. The question here is, we need to check what's the voltage differences between each element. So how to find this? So actually they have mentioned there are only two elements. If we consider this Z, we can directly tell we can easily find these two, whether this circuit is having the reactant parts or reactance or resistance. From that we can directly tell whether the circuit is having this resistor or inductor or capacitor. But here there are only two. However, from this part you can directly tell, as this is having the impedance is having in the 53, we can tell it's going to have a resistor, the reactance part, resistant part. From also it's going to have the reactant parts, so that it's the positive reactance part, so that we can directly tell it's going to have only inductor as well as resistor. It's not having a capacitor because they have mentioned whether there is only two elements. However, also you can check, you can directly tell if there are only two elements, you can tell it's going to have inductor as well as resistor directly. How to do that is, if you consider this part, from this part you can tell the voltage is going to lead the current. As we have already learned, if there are any inductors only, the voltage is going to lead that current. If there are any inductors in that circuit only, it's going to lead that voltage. The voltage is going to lead that current. So from that here we can directly tell the voltage is going to lead this current. So from that we can tell there is always an inductor. However, to find whether there is any resistor or resistance, you need to find this impedance. After that only you can come to a conclusion whether there is only resistor or reactance. So from over here, if you can directly divide this into two parts, resistor and reactance, we can directly tell that resistance part is going to use in that resistor, and the reactance part is going to be in that inductor. So that's the part we are going to do for this one, to find the value of the resistor and the inductance of that inductor. So here I am going to use this calculator to change this polar form to Cartesian form. From that only we can find the resistor part and the reactant parts. Otherwise you can find it by, let's say this is the resultant impedance 50.095. If we draw like this, we can tell this is going to be the resistant part in the real axis, and if we consider the complex axis, we can tell it's going to be the reactance of that inductor. So this actually we knew this 153. From that we can tell 50.095 into sine 53, and this is cos 53. Likewise you can find this one. Otherwise you can directly change it to Cartesian form. These both are the same methods, but the names are different. So let's say I'm going to change it for Cartesian form directly. Actually we have already done this one in the previous video, so I'm going to do a little bit faster here. I'm going to change the output. Okay, let's write this one 50.095. the angle would be 53. I'm going to make equal, it's going to be 30.147. If we approximate the values, we are going to get 30 plus j into 40 omega. From that we can tell this is going to be the resistance of that resistor, and this is going to be the 40 would be the reactance of that inductor, Ri. Either you can tell Ri, or it's better to tell Xi, this is a reactance part. So the next one is, the question is, we need to find the voltage differences between each element. So how are we going to find this one is, actually we knew that the resistant part and the reactance part, which simply means, let's say this is the resistant part. This is resistant part. Let's say there is an resistant part as well as the inductor part. Okay, this is the inductor. So if I consider the inductor, we can tell it's going to have the XL. Let's say this is XL. So after that we knew the value for these two, 40 and this is 30. As these are in the series, we can directly tell these two going to have the same current, which is, we knew the RMS value, which is 2.823 ampere. Here also we can directly mark it like 2.823 amperes. So the question is, we need to find the voltage over here. How we are going to find the voltage? Let's say this is VR and this is VL. Actually we knew the equation VR, or V is equal to I into Z. That's the equation we are going to use over here. So actually we need to find the voltage. So I'm going to use this one. VR is going to I. The current would be 2.823 ampere. But remember, when you are considering about this part, the thing over here is, you can directly use this one, and we are going to use the Z part, as we can directly use the Z part is going to be 30, as we are going to use the IRMS value and we are going to multiply this by 30. Some might have the doubt whether we need to use this phase angle over here, this phase angle. So the simple answer is, you don't need to use that phase angle over here. Is the reason behind this is, we actually knew that we are going to find this voltage to only this resistant part. So actually we don't need to use this I. Let's do some further calculation after this to identify what's mean by that. And let's say this, the VL would be I into 2.823, the RMS current for that XL, and after that I'm going to multiply by that Z. It's going to be the Z that would be 40. So actually you don't need to use that 83 over here. The reason is, as we are going to use the polar form directly, this is going to be the 0. So this is going to be the 0. So I'm going to use that later. So I'm going to multiply these two first. 2.823 into 30. So it's going to be 84.69. After that I'm going to use for this part 2.823 into 40. 12.92 voltage. So now we have found this. So the answer is this is the VRMS value, but they are only asking whether they are asking about the polar form or whether they are asking this voltage in the polar form or no. Here the question is they are only asking about the voltage difference. They are not asking about the to represent this voltage in polar form. If they ask to give the value in a polar form, then you need to use that equation, then you need to use that polar form to find this one. If you use this, we can tell, let's say in this question they haven't asked about that. If they ask about to find this voltage in the polar form, you need to use that polar form equations over here. If I use that, it's going to be 2.823, the angle is minus 83, and the 30, so the 30 is going to have the angle of 0. The impedance angle would be 0 because the resistance would be in the in the real part, so the angle would be 0. If I multiply these two, it's going to be added and it's going to return the minus 83. Likewise, if you do this through this one, it's going to return the minus 83, and it's going to be the plus 90 degree phase angle. So minus 83 plus 90 is going to return the 7. So these are the two different voltages if you consider the polar forms. So here they haven't asked about the polar form. However, if they ask, you must use the phase angle when substituting these two values. So when we are considering about this, let's say the total voltage. How to find the total voltage is, as they are in the series, we can tell it's going to be VR plus VL. So we need to add these two. So be careful, you can't directly add these two directly because they are having two different polar forms. So I'm going to use this calculator to this one. So however, I'm going to change this part to polar form. Let's say this is, I'm going to return the answer in the shift menu, complex, and okay 2. So the VR part is 84.69. The phase angle would be minus 83. Okay, and I'm going to add that this part is going to have 112.92. The phase angle would be 7. If I add this, I'm going to get the value of 141.15. The angle is minus 29.86 voltage. So let's check whether these answers are correct. If you consider this part, you can directly, it's going to be the same. It's nearly, if you approximate these two values, you are going to get this value. This is the source voltage we have given for that circuit, series circuit. So the answer we have get here is the correct part. If you add these two, we are going to get the same value. So the next part is, we are going to representing each. We need to use this phasor to represent each component's voltage. So actually it's the same like this part. However, when you are considering this part, we have drawn for voltage and I for the same circuit. However, in here we are going to draw for voltage but for these two elements. So when we are drawing for phasor for these two, actually you need to know these two values, otherwise you can't draw this one. So if I draw a reference angle like this one, we can tell the voltage for that resistor would be in this minus 83. It's going to be 84.39. Let's say this is 84.69 voltage and the angle is minus 83. Likewise, we can tell this 7 is going to be the 7 degrees and 112.92 voltage. So these two you need to specify. So the next part is, before that I'm going to multiply VL and VR. Okay. So the next part is express the voltage across each component in the time domain, which simply means in the previous question actually we knew the value of this. After that we have converted to this polar form. However, in this question we already find the value for each component's voltage in the polar form. We are going to change it for time domain portion. So when we are considering about the time domain portion, actually we knew that the equation is V is equal to the time domain, Vt is equal to V maximum voltage of that, the voltage time domain, and it's going to be sine omega t plus initial angle. This is the equation. We need to substitute the values. So when we are considering about the V max for this R component, resistor component, actually we knew the value of 84.90. This is the RMS value. So when we are considering about for that V max, actually we knew that the V RMS would be equals to V max over root 2. So from that we can tell the V max would be equals to root 2 into this value 84.69. So if I simplify this, I'm going to get 119.77, and we are going to substitute for these values also. Sine omega would be, actually we need the omega of that voltage, it's going to be 1000 t plus the initial phase angle of resistor is minus 83. Be careful of that. So minus 83. Likewise, you need to find this is for resistor. For that, likewise, you can directly find it for inductor too. So this is the part you need to do, and I hope I have explained it clearly. If you have any doubts, please comment it below and watch our previous videos as well as our next videos also, so you will be getting you will be understand these concepts very clearly. Thank you for watching.